Hey, grade 10s. I hope you're all doing well. I am stuck at home, sick, quarantined. I have a stuffy nose and a bit of a sore throat. So I did my COVID-19 test. And if and when that comes back negative and I'm feeling better, I'll be back at school. So hopefully that's really quick. I really don't know. So I just wanted you to know why I'm not there, and I'm doing these lessons from home to help you guys out and help out the substitute teacher as well. So today is a review of balancing chemical equations. And before we do that, I just wanted to make sure, and for those of you that were in Science 9, that you understand how to count atoms correctly in an equation, because that's critical to being successful. So we're going to look at this equation, which is from your assignment the other day, H2SO4. Whoops. So if I asked you how many hydrogen atoms are in this molecule, you would say 2, 1 sulfur, and 4 oxygen. Now, when we balance it, we're adding a coefficient. So this has a 3 in front of it as a coefficient. So that 3 is multiplied by everything. So that means 3 times 2 hydrogens for a total of 6. 3 times 1 sulfur for a total of 3 sulfur, and 3 times 4 oxygen for a total of 12 oxygen. Okay, let's do one more. Oh, let's do a couple more. Okay, AlOH3, 2 of them. So how many aluminum in total? So 1 aluminum, the 2 in front applies to everything. So that means 2 aluminum in total. How many oxygens in total? Okay, so you do the subscript first. There's 3 oxygens and 3 hydrogens in this OH. So 3 oxygens, or O3, times the 2 in front gives us a total of 6 oxygen atoms in that molecule. And for hydrogen, we have 3 applied to the H, so that's like an H3. And the entire thing is times by 2 for a total of 6 hydrogen. So they're tricky when they have a subscript. And I'm going to put a coefficient in front of here, a coefficient as well. So what would this one look like? Okay, so let's do aluminum first. So there's an Al2 times 3 for a total of 6 Al. Sulfur, so these brackets means the 3 goes to both. So that's S3 times a 3 in front for a total of 9 sulfur. Okay, now oxygen is 3 O4s. So that's like having 3 times 4 is O12. There's 12 oxygen atoms there. And then the whole thing is times 3 for a total of 36 oxygen. So hopefully that makes sense to you. And there is a worksheet to practice in your guide on page 64, 65, if you feel like you need to review that. Okay, so balancing chemical equations. First step is you must have the same number of atoms on both sides. Atoms are conserved, and that's why we just did that little practice to make sure you can count atoms correctly. If they aren't the same, you are only allowed to use coefficients. Okay, you cannot change the subscript. So let's say, for example, I'll put it down here. Let's say, for example, we had CO2 and you needed 2 carbons to balance it. So it was CO2, and then on this side it was 2 CO3s. So how do I get 2 carbons? Am I allowed to add a 2 like that with a subscript so that I can balance 2 carbons with 2 carbons? No, you cannot. You can only add a coefficient to balance the carbons. By doing that, it means that there's now 2 carbons, but this 2 multiplied by the 2 there means 4 oxygens. So we're not balanced. because now I have 2 carbons and 4 oxygens, and on this side I have 2 carbons and 6 oxygen. So I would have to change this to a 3 to get 6 oxygen. And now that's going to mess up my carbon. So this one never balances. I'd need to have another oxygen over there, but you get the idea. Back and forth. So we'll do some realistic examples. Just want to get rid of that. So coefficients only, not subscripts, is the moral of the story on that one. Okay, some rules. If you have polyatomic ions, balance those first. Balance anything that has a large number of atoms or ions. So I always say complex molecules first. Get those ones balanced and out of the way, the atoms in the complex molecules, and then go to the individual elements last. And usually those are oxygen and hydrogen. Sometimes it's easier to write water as HOH because that's often how it reacts. You'll see it turning into H2 and OH on the product side. So this way you can split up the water when you're balancing it with H's and OH's. And once you've got it all balanced, make sure that you've simplified your coefficients. So if you finished with 2x and 4y, and you get 2xy2, we can simplify that to 1, 2, and 1. And your last step is to go through and just do an atom count to make sure they're balanced on both sides. Really, the key to balancing is practice makes perfect. It's kind of like all the chem we've been doing so far. Practice, practice, practice. At first, you're a little slow. It's like riding a bike. Once you get your balance down, it gets easier and easier, and then pretty soon, nothing can stop you. So we're going to go through some practice examples, and these ones are located, well, you have them in your notes, so let's take a look. Okay, so start with the most complex molecule first, this one, and get it balanced. 1 aluminum, 3 bromine. So I go over to this side, 1 aluminum, 2 bromine. So whenever you have 2 and 3, our common multiple is 6. So the lowest number that these will both go into is 6. So I'm going to put a 2 in front of there. 2 times 3 gives me 6 bromine. 3 times 2 gives me 6 bromine. Okay, the bromine are balanced. Now the aluminum, there's 2. And because we left this element until last, when I put a 2 in front of it, that doesn't affect anything else, and we're done. Quick little check. 2Al, 6Br, 2Al, and 6Br balanced. Excuse me. Okay, second one. Again, start with the most complex molecule first and get it balanced. 6 carbon. Here's my only carbon, so it must have a 6. 12 hydrogen. Hydrogen's only found in this one spot. So I put a 6 in front. 6 times 2 is 12 hydrogen. 6 carbon. Now, all I have left is oxygen, and that's good because we have oxygen as an element. So when I go to balance, one number in front of here will solve it all. So what's the magic number? Okay, so I have 6 times O2. So 6 O2s is 12. And then over here, 6 times O, 6 O's. So I have 12 and 6 is 18 oxygen. So on this side, I need 18. There's 6, so I have to minus 6, which leaves me with 12. So what number am I putting in front of O2 to get 12? 6. And that gives me my missing 12 oxygen. Now, if you want, you can do a quick little count. So I have 6 carbon, 12 hydrogen, and 6 plus 12 is 18. Let's put it here, 18 oxygen. Okay. On this side, I have 6 carbon, 12 oxygen, 12 hydrogen, and another 6 oxygen for a total of 18. 18, 18, 12, and 6. We're balanced. By the way, no number is the same as a 1. Okay, NaH2O. This guy is probably the most complicated. Now here's an example where water is turning into OH and H. So I find it easier to write it like this. Okay, so there's my OH, there's my OH. 1 and 1. 1 sodium, 2 hydrogen. Okay, so I've got 2 hydrogens. The Na and the OH are balanced. OH and A. I'm just going to switch my color. Let's go red. Okay, so this is tricky because I only have 1 H here and I have 2 there. Can I put a 2 here as a subscript? No, of course not. I have to put a 2 in front. Okay, so now I have 2 hydrogens to go with these, so we're good. But this number also applies to the OHs. So now I've added a second OH. Can I put a 2 there? Of course not. You're getting tired of me asking you that question. So that means a 2 in front of there. So I'll just check that. 2 hydrogens, 2 hydrogens, 2 OH, 2 OH, 2 Na. So now I have to go back to this Na and put a 2 in front. And we're balanced. 2, 2, 2, 1. Okay. What do you think is the most complex ion out here? This guy. Start there. 1 copper, 1 copper. Polyatomic ions, if they're staying together on both sides, so here we have an NO3 and here we have an NO3, then leave it together. Don't try and balance the nitrogens and oxygens separately unless it has some nitrogen or oxygen in another spot. And this doesn't. The only nitrogens and oxygens are in the polyatomic ion, so we'll treat it as one unit. So that means 1 NO3, 2 NO3s, so we put a 2 in front. Now we have 2 NO3s on this side and 2 NO3s. They're balanced. 1 copper, 2 silver, and 1. So we need a 2 silver. Okay, awesome. Now we're going to do another one, and I don't really see a lot of space here. So here's some space. Okay. This one is, just to show you, a little more challenging. You don't have this one in your notes. C3H6N4O plus oxygen. And I'm just going to skip states on these. No, actually I won't. So that's a gas. That's a solid. And we produce carbon monoxide gas, water, and nitrogen dioxide. Okay, where would you start on this? This guy. So let's balance the atoms. 3 carbon, 6 hydrogen. Okay, HOH, 2 hydrogen in there. I put a 3 in front and I get 6 hydrogen. So I've got 3 carbon, 6 hydrogen, 3 carbon, 6 hydrogen, 4 nitrogen. Here's my nitrogen, 4 nitrogen. And 1 oxygen. Okay, oxygen is everywhere. Here, 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 here. So we leave the element until last. Balance everything else if we can. So what have we got right now? I've got a total of 3. I'm just going to make a little list here. 3 oxygen, 3 oxygen, and 4 times 2 is 8. 8 and 6 is 14. Okay, so we have a total of 14 oxygens. And on this side, I need 14. So I have 1 here, That should be 1 oxygen. So that really means I need 13. How do you get 13 when it's an O2? Can I write a fraction? 13 over 2 times 2 equals 13 oxygen. Nope, you're not allowed to use fractions. So when you get a fraction for your oxygen, and this often happens with combustion reactions, because this is combustion, we're burning by adding oxygen. Instead of putting 13 over 2, we're going to write 13. Now the problem is that doubles everything, right? And so to fix the rest of the equation, we just go back and every 1 turns into a 2, 3's turn into 6, 3 turns into a 6, 4 turns into an 8. So we double everything because we doubled 13 over 2. 13 over 2 times 2 is 13. Now let's just double check and see if we got this thing right. So total number of carbons is 6. Total number of hydrogens is 12. Total number of nitrogen is 8. Total number of oxygen is 2 plus 13 times 2 is 26. 28. Okay, over on this side, we have 6 carbon. Yes. We have 6 times 2 is 12 hydrogen. Yes. 8 nitrogen. Yes. And a total of 28 oxygen. Well, let's see. We have 6 oxygen. Where am I going to write this? Well, I'll use this list. 6 oxygen, 6 more oxygen. 8 times 2 is 16. So 12 and 16 is 28. 28. It's balanced. That is a beast. That is as hard as you would see in 10 advanced. It's a good one though. Now that you've seen the toughest, nothing will scare you. Okay, so you have some time in this class to practice balancing. And if you want to warm up, it says optional to ease yourself in. You could do page 64. 65. That's optional. And then must do pages. Where are we here? Balancing chemical reaction equations. Okay, so it is page 70, 72, and 73. And answers to this will be posted in Google Class for you to check. If you get all this done in class, then you have additional time to go back and work on your labs. Okay, and so where is that? Right back here. Oh, it's not even in this one. Shoot, looking in the wrong slide. So you have your lab reports to finish. You've got analysis, identifying the 10 unknowns, and evaluation. And that is in Google Classroom as well. The checklist is there for you. And you need to finish that off before tomorrow's class. And originally I had said it should be word processed as a digital document. Because I'm not there and because you have a bunch of time in class today, if I was there, I could probably get a Chrome cart for people that wanted to work on it in class digitally, but it's not an option today. So to make a long story short, you can continue to word process it if you would like, or you can hand it in handwritten as long as it is very neat. If you are sloppy, you need to word process it and hand it in to me as a printed out digital. And if it's printed neatly, then you can hand that instead. So what that means is you have time in today's class that you can actually start writing out your good copy of your lab report to hand in tomorrow once you get all these balancing pages done. Okay, hopefully that makes sense for you and you've got a big chunk of time. Don't waste it. You can dig into that right away. Okay, have a good afternoon and I hope to see you guys soon.